It's everyone from here, from Rome or Italy? Okay. Very good. I asked her about the food because like Italian food is great. All what for you is just food, I know. Like every day you eat food and it is Italian food, but know that it's very appreciated for people out there, especially for me. Okay, so thank you for your attention today. I'm going to guide you through the document. We're going to build this together. Okay, you might have access to it. If you don't have already, you can connect to the Wi-Fi network and the password here. And you can all access this document through this link. Just type in your address bar, you should be able to access it. And you do have permissions to edit, to read and access it. And I'm going to ask you for filling your name here. You're going to find the Luma link here. So someone though that didn't subscribe yet, you can enter this link because it's going to be important for you to be registered and you can receive a certificate later on. Okay? And everything down here I'm going to guide you through. You can see here that you have a table for filling your name, your email address. Okay, you can add more columns here if you need. If you don't have a wallet address, don't worry. This is one of the things that I'm going to explain here on day one. Getting started is using a wallet, so don't worry if you don't have a wallet address at the moment. If you don't know what a wallet address is, leave it blank. We can return to this later, okay?
Sorry, can I ask you to show the short link again?
Of course. Yeah. Okay. So it's very important that you have access to this. I'm not going to be just showing information all the time. I'm actually going to invite you all to code together with me. It is a hands-on bootcamp, hence the name. So it's important that you can run the things in your computer, that you can access the link, that you can remember where to find stuff later on. The best way to make you remember those things is to practice. Okay.
Everybody has to fulfill the ticket?
You have registered through Luma, right? Okay, so you have to register with this link. And for today, I've asked you for filling your name here. Email is optional, and later on we're going to need wallet address because we are going to be interacting with each other. See? So
Because there's not enough role.
you can add more. You can. Let me do this. You do have rights to edit the document.
It's not a problem that everybody can see each other's name and email and also wallet address. It's
Yeah.
like a little bit of celebration.
If you don't want to put your email, that's okay. Your name and wallet address, I'm going to explain this. So for example, you don't need to use your production wallet address.
Non ho visto quella dell'Indra.
Clarissa. Sorry? I'm going to explain. Don't worry. Just trying to fix that. Clarissa, who is that? Clarissa, I've put you down here. Just okay. Just then we put the number here. Okay. So who still doesn't have access to this link? Like raise your hand. Everyone has access to it? If you don't have a device, don't worry, you can. Okay. Yeah, because I'm going to scroll down, so if you have access, you can follow on your own screen. So I trust you not to mess too much this table, but I'll leave it as it is. You'll go feeling later on. And I'm going to show about wallets now, so if you don't have a wallet up there, don't worry. Okay, all good so far? Okay. So, about our schedule. I want to prepare you all to hacking this weekend. Have you heard? We have a hackathon coming, right? So how our 5 days are going to look like? If you guys need more power outlets, we have some extensions in the back. Marco, if you have the extensions, 1 or 2, the power cord. Because you're going to need power, right? Your computers need to last for 4 hours. Okay. So, in those 5 days, we have a good schedule ahead of us. I want to prepare you all for this hackathon. I want to prepare you all for winning this $5,000, right? That's the most important part. No, but prizes are good. We have hackathons with $1 million prize out there. It's not that difficult to find. For example, last hackathon I attended, New York, had $1 million prizes. I guess the guys went for the Istanbul one, had more than $1 million as well. Of course, dividing a lot of prizes. But imagine, you can learn something in a week and then you start earning money for that. It's awesome, right? But even better, if after this you can build a project. After this, you can build a product. I don't know if you have this entrepreneurial willing of building another thing, a new company, but also you can get hired for some company if you're looking for it, you know. And sometimes this process takes months to happen. I'm going to try in a very practical, objective way to shorten it to 5 days, plus a hackathon. Just see if I'm counting on you on that. I'm going to do my best, but you need to do the other part to get you ready as soon as possible to start building for Web3, right? So in the first day, we are going to do an introduction about smart contracts. What are smart contracts? And I want to demystify a lot of things about this. What are decentralized applications? What are blockchains and how we use them? Why they are important? Just this is enough for example, to stopping fake news or fake information about blockchain. Day 1, we are ready here. Day 2 and 3, we start programming with more advanced tools. So for example, we're going to use VS Code. We're going to install things on your computer. Today, you just need internet connection in a browser. But starting tomorrow, I'm going to ask you to install some of the other things so you can build like a pro. Simone introduced about Venture Miner. We have a software factory there, so we produce production-grade software. So we are going to present you softwares that are used indeed for building projects. It's not just some educational toy tools. Are actually that you can use this for build things. And day 4 is all about building the apps. So Kevin from Build Guild is going to present Scaffold ETH, a great tool for that as well. So you can build the apps for Ethereum, for Arbitrum, for any compatible chain. And then day 5, we are going to exercise together. We're going to have some talks, some group exercises before the real day, that is Saturday. We start coding for real, competing, okay? So you can start sabotaging everyone and giving alcoholic beverage to your friends so they drink and you keep coding, right? So all of this is start on Saturday. Until Friday, we are all friends, okay? Good? Okay. Let's begin then. Everything ready here with that messy table. Let's see. Looking good. We have how many here? If the counting is correct, we have 44. That's great. Let me try and format this. Don't know what happened here, but okay. No, okay. It's just massive. Let's leave it as it is. I'm going to start by asking, what do you know about blockchain? Like, raise your hand. What is your, doesn't matter if it is right, if it is wrong, if it's just your opinion. If you think that blockchain is just a fancy way to do scams, that's a valid answer. A lot of scams are doing blockchain, unfortunately, but raise your hand. What do you know about blockchain? I guess the microphone is not working. They can hear me. If any of you, okay, back there, you two. Okay, what do you guys know about blockchain?
I can talk about the Ethereum blockchain. This is what I know the most.
Yeah.
I think that it's just a list of information, and every block of the chain, every block of information has some metadata about the next block and the previous blocks to maintain integrity. And smart contracts are just programs written in a block of the blockchain that get executed by a virtual machine, in particular the Ethereum virtual machine. And you have some limitation about space, how much space you can use in a program, how much, I think, token you can write in a program.
Okay,
so
a lot of concepts.
Very efficient about the variables that you use, line of program that you write, about splitting your programs in efficient blocks.
Okay, so you have information dividing block where each block is related to the previous and next one, and they all run inside a network that you can build something called smart contracts that can execute data, and they can be split in efficient ways to do things like tokens. Are you keeping track of the amount of keywords we are speaking? You want to complement your name? Sorry? You raised your hand, right? Yeah. Your name? Andrei. Andrei, what do you know about blockchain?
Blockchain is structure of data, and each node of this list contains its data,
A copy of the data.
The copy of the next and previous block, but in crypt form, and the advantage to use this structure is there is no only one people take the control of data, but is distributed, and
so like you have censorship resistance. If you take one node down, you still have plenty of others around, so you don't lose the information, right? Yes. So we are slowly building up here something interesting. We look at the blockchain. we see that it's a network to store data, we can run programs on it, and it's shared on each node, so you have censorship resistant, you can take down information without taking down all the network. It's looking good. Perhaps 2 or 3 more people. It doesn't need to be technical answers like this. It can be, what do you know about, what do you have heard about in blockchain? That's good for me. I never heard about blockchain at all. That's the first time you heard cryptocurrencies. Okay, that's great. This is good, I can work on that. So you have a clear impression, and that is even better than a bad impression, okay? You?
I know that is an incredible power calculation.
Oh, good, yes. That's a good statement about it.
The idea is for not depends on the banking system or government decisions. It's something that is completely decentralized from decisions of people in power, and it's the community that takes the decision.
Yeah. Are you Satoshi?
I wanted to.
Perhaps you are, and you know. Do you guys know Satoshi? Satoshi Nakamoto?
Yeah.
A person or a group of persons that invented Bitcoin. So the answers are good. Any more? Like, raise your hand. You.
Basically, it's on track, so you cannot hide.
Yeah.
Because if you want to push up cash on the wallet, you have to use I don't know, Binance or exchange, then or another, and from your wallet they can track everything you did with that wallet, of course, even with the other protocols like Tornado and several.
This is why you didn't want to put your wallet there, right? But we are going to create new ones, don't worry. Good, that is correct. Anyone else? Okay, I like to bring this up, people, because our perception of something creates our expectations. It prepares some places in our minds that we are going to fit that thing. So when people come to learn blockchain with all of those technical concepts and sometimes even some biases, it's difficult to properly focus or properly direct the understanding to what is actually a blockchain. And this is what I'm going to try today. I'm going to try to give you a very practical understanding of how to use a blockchain, how to code inside blockchains, inside decentralized networks actually, and what we can do with it in 5 days. Okay? Because to answer all of those concepts you have been mentioning, it will take like 6 months. If you guys want to take a 6-month course, that can be arranged as well, but it's not what we are going to do. We have just 5 days, 4 hours per day or less, because we have snacks that are very important as well. So what we are going to do here is have a very, very pragmatical approach on what is a blockchain. And to give a parallel, I do like metaphors a lot. Please bear with me on that. How would you, for example, explain internet? One person to quickly explain what is internet. Yeah. Magic. Power.
Internet is
Sometimes it's difficult to put in words, right? Yeah.
is a network of many services who you can access in the remote mode.
You can, through the internet, through HTTP protocol, for example, access the remote content in another server, right? Yeah, it is hosted somewhere in the world, in China, in Europe, you don't know, but you can go and access that information there, right? So you have a protocol to connect those computers, you have protocols to communicate, you have the IP protocol where you can find those registered in the internet and all of that, a lot of words, and you are like this, hey, what I signed up for, and hey, chill. Internet is a place that you can go for a tool called Google and search for cat pictures. That's internet. Okay? Not all of it, of course, but half of it at least. Probably. Yeah. Give or take. So this approach to internet, I can explain this to my mother, to my uncle. Internet is a place that you can go and search for cat pictures. So you don't need to go hunting for cats. You just find them in one place. Magical. If you explain the technicalities of the internet, that is a bunch of computer and all that, that is 100% correct. That is good when we can see the engineering part of it. But it cannot precede the use. The use should come forward. We just use things because they are useful for us. Okay? Yeah?
Cioè, what happening technically is when you search cat pictures, you send a request to the
Google servers? Yeah.
To the server who hosted the picture. In this case, the request is sent to Google. He analyzes the request and return you output the image of the.
Yeah. So all of this structure behind is very important. So for example, you'll know that you can't download random pictures without, for example, risking yourself to get a virus. Or how to properly serve billions of pictures of cats per day. So this is very important to know after. Before, you need to understand the use of it. How to actually use the internet. So this was a big discovery back in the 90s. Until we found that we could sell things on it, that we could watch movies and other things on it, play games, then internet became a thing. Before of that, it was just a nerdy stuff that some university students in the 70s and the 80s used it to communicate between themselves. And then we can't live a day without the internet. Not even if you want. You can leave your phone away, but you are going to experience a contact with the internet sometime when paying something, when using something, when seeing an ad and all of that. So the same thing might happen with blockchain. As soon as we remove the technicalities forward and start to understand what the blockchain is and how to use it, what Web3 is and how to use it, and then we learn the technical parts behind it. That is what I'm going to do in those 5 days. So it might fast track you to that. Okay, you had a question? Okay, question.
But like always my doubt was how do you internet like in the 80s was like not the internet of today. So how do you update it like the blockchain? I mean,
yeah.
The services on internet like all the time like probably today every day you just like have updates about design, UX design, and everything.
That's a good thing. The internet used today is basically almost the same architecture as we have in the 70s and 80s. But what changed is because people saw value in it. When people see value in it, it comes investors, money, markets, demand. And then when you have this, you can apply for engineers that need to work, need to be paid, need to eat, and need to live, right? So actually start hiring money and build things. The same thing with Web3. Until we foster that, until we have a spring of applications, of real use cases to actually drive people in, drive investment, drive demand, drive attention, we are going to still struggle for it to update. Okay.
So like it is different about like the system and the product.
Yeah.
Like you know, like when I think about decentralized stuff, it's like I can not have control in it. Or
Yeah.
maybe I just have a little bit of control, but like you know, like
You have some influence.
yeah.
And the internet back in the 70s and 80s was something decentralized and all as well, until some giants took over of it, and it happens. Okay, for better and for worse, it happens. We might see something similar with Web3 as well. Those are great questions. Okay, I guess it's setting the tone. Good, we are in good direction. So okay, so if internet is a place that we can search for cat pictures, what is a blockchain? A blockchain, to quick start this, is a place that I can have assets. So this is my wallet address. A place, an address, like a street address. Imagine like a place. You don't need to worry with the numbers and letters here for now. It's just an address that I can have assets on it in my wallet, and I can transact those assets. Let me show this first, and then I'm going to teach you how to do this. So this is my wallet. I'm rich. Yay, I'm going to spend it all. This is fake money, okay, don't worry. It is. I'm going to teach you how to get fake money as well. Not Brazilian fake money, like it's useful fake money. And I can transact that. For example, we have people here that have address. So Francesco, sorry if I'm spelling your name correctly. I'm using a testnet, so for example, I won't be able to resolve your name here. I would need to resolve mainnet first and then come here. So for example, if you want to put your address, or for example, I can pick Jordan's address here. Jordan?
I'm becoming rich.
Yeah, I'm going to send you money.
I'm like the second guy after Jordan.
Too bad. So the same way that the internet is a place that we can search for cat pictures, blockchain is a place that I can pick Jordan's address and send you, Jordan, a big sum of money here. That's too much. Okay, that's better. You're going to have problems in your annual declarations of money, right? So I'm going to send this transaction, confirm, okay, sending. And the network is going to take care of processing this transaction for us. Like a bank account, like a bank transfer. Okay? So all of those stuff about blocks and transactions, now it's true, we are going to see all of that. But to summarize, for us to start actually, blockchain is a place that I can hold assets and transact those with transactions, okay? Like a bank transfer. And that's it, that's good, a good starting point. You might be like, so it's a glorified bank account. Let's start with this. This is a use case. You can transact assets here, okay? The good part of that system is that you don't depend in a server to run that, a single server, a single point of failure. You cannot be stopped from sending that transaction. Like, no one can say hey, you can't send transaction for that person. Okay? Or you don't have access to that money anymore. Okay? Imagine me saying that for my wife. Okay? That's not how blockchain works. It allows you to use your money anytime you want. Okay? So, the network that creates that possibility is that blockchain thing that running all of the nodes. Now it's starting to make sense. We can explain those concepts after you see them in place. So Jordan, this is your address, for example. I can use one application here called Block Explorer. I'm going to show that for you. That is a web application, a website that you can access. Let me put here on the dark mode, okay. Light attract bugs, so I always use dark mode. And I'm going to search for your address in this website, in this application. And now it is public. I can see that your address here contains this balance because you received that transaction. And everyone can check that. Okay? Only people that have access to that document can link this address to Jordan. So that's okay. Yes, your address you put is doxed, I know. But other than that, you are just an address. Anonymous address that is able to hold some balance here, some assets. Okay? Starting to make sense? So you know what's blockchain now. Okay? Good. That's important. Every 10 minutes of lesson, we should learn something. We should have constant progress. Okay? And bear me with the bad jokes. It's just to keep you interested. Our attention span is very short. So I need to do magic to keep you interested in me. We are going to start then with our first practical task. All of you that don't have a wallet address field here, you can install in your browser or even in your phone this wallet application, MetaMask. Is that little wolf here. It's not linked to Urbe, but I guess it is a fox, I guess. It's an inspiration. My little fox here, it is pink, okay, because it's another version called MetaMask Flask that do exactly the same thing to this MetaMask. So don't worry if your little symbol doesn't look like mine, okay, it's just different. So you go and install this in your device. You download this extension for Chrome browser, for Firefox, for Edge, Safari, I guess, it works as well. Or Brave, Opera, there are many browsers that you can do that. And then you fill your wallet address here. Because we are going to do experimentation, just like I did with Jordan, okay? So you are going to download this extension. It is going to give you a seed phrase. Do that now in your computer. It's going to give you a seed phrase, and you are not going to register with your email and password or whatever, like log in with Google, log in with Facebook. No, you are going to create that identity with a seed phrase. And that seed phrase could be written in a paper. You don't need internet for that. You just create a wallet, and it's going to give you one identity in the network. Okay? Do that and you know what I'm speaking about. Okay? If you already have a wallet, then you can wait a little. And if you have a wallet that has money on it, like it is your production wallet, your mainnet wallet, please, for all that is sacred, create another one for this bootcamp. I don't want people to lose money, to spend mainnet money. For example, if you leak your keys, you can be hacked. So, like, if you are concerned into putting a wallet in the document, create a new wallet. You see, you download a MetaMask to another browser in your computer, or create another user. Just don't use your mainnet wallet for this bootcamp, okay? For anything development related.
For the ones using MetaMask from the mobile, I don't want to use another wallet, but is an option to make another one with the same seed phrase. I can use that.
Every wallet you derive from a seed phrase can compromise your seed phrase if you do it wrong. Okay. So.
Of course, if I compromise one of the two wallets, I got compromised good, but I don't want to check out from my actual wallet from my.
Yeah.
And wait for tomorrow.
Perhaps you bring a notebook tomorrow and use an or perhaps I guess you can create application profiles. I don't know. You have Android or?
Android.
Yeah, in Android you can have
do it now. Thanks.
Okay.
There is another way. There are websites that you create, from the private keys, they create the wallet, the scanners.
Yeah.
Scanners. You can just pick a private key from there, and then put it to MetaMask, and it is not associated to your seed phrase.
Yeah, but then you are going to just have one wallet, right? Because, for example, if you create more wallets with a seed phrase, you just need to remember your seed phrase. Later on, you can recover all wallets.
Yeah, but if you activate just use on testnet on Arbitrum.
Later on, we are going to use for the app development. So, for example, we are going to have an env file and all of that.
One for each chain.
Yeah, that's good. Okay. This wallet you are creating, people, important information. It is the same wallet for all compatible networks. Okay? The wallet is not a part of the network itself. It's another entity. Okay? It is your cryptographic key. Don't worry with the cryptography part now. That can enable you to sign transactions for that address. It can happen in the Ethereum blockchain, it can happen in the Arbitrum, it can happen in Optimism, it can happen in any other chain. You just need your seed phrase, okay? So it's not like I'm creating a wallet in Ethereum. No, I'm creating a wallet in Bitcoin. It's a different architecture of wallet, but it's not pertaining to that network. It's your wallet. You can use that for signing transactions in a lot of compatible networks, okay? I'm saying this because some people think, hey, I'm using this wallet in testnet, but it's not my mainnet wallet, but actually it's the same wallet, and people have lost money like this. So remember that. It's one wallet that you create, you can sign transactions in different chains with that same wallet, okay? It is important to remember that. Okay. Questions? Questions? And the safest way to store this is memorizing the seed phrase, okay? Remember it in your head. You're never going to lose it. Just kidding, write it down. If you're ever going to use mainnet, it's always good to have a physical copy of your wallet written down somewhere, like in a safe or whatever, because it's easy to lose those things. Okay.
But if I lose my password, I can ever access to my wallet again.
You just call Vitalik. He can restore your account. Just kidding, man. But if you lose your seed phrase, if you lose your password, it is gone. No one ever can recover that. Okay.
There are the safe words, like the password and the word.
Yeah, if you lose your password, you can use the word. But if you lose the words, and let's say you wipe your device, or someone steals it from you or whatever, and you lose access to that, if you don't have the seed phrase, the password is not going to help. You need the seed phrase is the most important. The password is just important for your device. Okay? I'm going to explain more about the wallet after you create it.
Access our wallet address from different providers like MetaMask or from another application?
Yes, you just need a seed phrase. The seed phrase that you put in MetaMask is going to give you access to sign transactions for the same address as if you put on Trust wallet, on my wallet, on my Mycelium or whatever. The seed phrase is the king. Okay. Okay. So when you create your wallet, you are probably going to see something like zero balance. You're probably going to see something like this, and you are going to be connected to the Ethereum mainnet. Okay. So this is probably what you're going to see. Okay. You have your address here, your balance. Here in the left corner is the network, and you're probably going to have zero balance. Why I'm saying probably? We are used in Web 2 that when we create an account in a database in a server that creates that entity for us. So for example, the first time you register in Facebook, you probably don't have Facebook, I'm getting old. When you register in Instagram, in Twitter, in X or whatever, you have a blank account, right? It's created from scratch from you. Like you can put your username, then you can upload a picture, whatever. The first time you register in a bank, you have a bank with $0 inside, zero money inside, euros. So this is what we are used to in Web 2. Okay? Web 2 is the common web that we are used to. It's like Web 1, back in the days, static websites. Web 2 is the common web that we are used to. In Web 3, blockchain world, it's different. There is a small probability, very, 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 very small, almost zero, that you create an account and you have balance. Like, random winner, you are the 1,000 people to register an account and receive balance. No, it's not like that.
If someone did, like, for example, make a mistake and send money to their account, the address that you create?
Actually, no. Someone can find your money someday in blockchain, but it's almost zero probability. Don't get worried yet. It's just to understand what the network is. Pay attention here, people. What is happening? When we create those seed phrases, they are generated by random. There is no check if someone is using that address. You just create them by random. If you happen to open a new wallet and it has balance, you are the most lucky person in the world. But it's important to understand that, to understand the architecture and what is behind. When you create this wallet, what you're actually doing is choosing a random set of words that can sign transactions for. I mentioned that a while ago. And it could be that it's the same set of random words that someone used in the past. It doesn't check that when creating a new account. It doesn't check if someone has used those words. If you check, you already discover it, okay? You see, this is by architecture, by design. It seems like a flaw. But the thing is, statistically, there are more wallet addresses, possible wallet addresses in Ethereum than there are of grains of sand in the earth, in the whole planet. So imagine, I pick a random grain of sand in Brazil, I write my name on it with a very small pen and throw it in the world. And then you randomly find that grain of sand. The probability is almost zero. So this is why people have designed it that way. But it also means that no one can take that access from you. So long you have those words, so long you have the signature key, you can sign. This is the fundamental truth. This is the basics that say that blockchains are decentralized and permissionless. This single feature, this single mathematical tweak, trusting the luck, trusting the universe that things are going to work, is the fundamental feature that makes blockchain decentralized. Because you don't create an account. You don't ask to register. You don't go to a server and create a new entry, a new database, my wallet, you see? All the wallets are out there already. You just pick one random one to call yours. This is my wallet. I'm going to fill it with shitcoins. Sorry for the word. With NFTs or whatever. You see? This is a wallet. Okay, it makes much sense looking that practical way. So now that you all picked those wallets for you, some of you are having troubles. Don't know. Claudio, Federico, Beatrice, David, Luca, may I help you with getting wallet addresses? Sorry? Sorry for misspelling your names, okay? Italian names. But. Okay. And because all of those wallets are out there, for example, the last one here, Damiano. Yeah. For example, I can already search for your wallet. It works. You didn't make any transaction. It would work even before you created it. I can search for any wallet address I want. For example, 11. Let's see if it's going to work. Yeah, I search for another wallet address. It's not your wallet, it's another, and it works. Because like I said, all the wallets exist already. You just pick one to be yours.
So you already have all the wallets that they can exist and you can like just pick one.
By choosing random words. And this is what makes it...
The amount of letter and number, you have to create letters is like something.
It is derivated from your seed phrase. And from your seed phrase, you can create more and more wallets and sign with the same seed phrase.
About the address, like the zeros,
like those letters, and you don't choose it. It's just math. Yeah.
You cannot choose it, but it's like the amount of letter and number that the system chooses.
Yeah.
Is the amount that it can increase, or it's like...
It's the same, yeah. At some point, let's say we have 1 billion words populated by humans, it's possible that we run out of addresses, yes. That's a good question. More questions? Go ahead. Is anyone with troubles creating a wallet? So, yeah.
The wallet generated with a set of words in always the same language, or there is a language between various, or it doesn't matter?
Yeah, the word itself is just a shortcut for us to create the electronic signature. You could create it with all the set of words. You would just need another dictionary. Okay. What is important is the entropy there.
So it doesn't translate the signature, the letter signature. For example, we have the standard words, but for we have our words, the signature is like the same.
Yeah, the English is the standard dictionary. It can't be any word. It needs to be words inside that dictionary that has those words in it. But you can create new dictionaries. The important is the signature. Sorry? Yeah, each word is mapped to 32 or 64, don't remember, bytes that are part of the entropy that's going to generate your key. Okay? It's just a mathematical shortcut for that. Okay? So any of you were lucky enough to find a wallet with balance? No, right? Okay. Now I'm going to teach you how to get free money. Well, everyone paying attention now? What? But it's free fake money, okay? Because here you are probably connected to the Ethereum network. If you go for your network chooser picker, you're going to be in the Ethereum mainnet, okay? So there is an option here to show test networks. You need to enable that. It's not enabled by default. Because those test networks are nice places. Probably you're going to find here one called Sepolia. Here. Are nice places, let me pick my other account, that you can ask money for free. Fake money, you can't use that to buy anything. No one is going to sell you stuff for those testnet tokens, but it's good for us to test how the network works. Okay. You can ask Sepolia money by going to a faucet. Just scroll down in the document. You are going to find those faucets here. And we are going to ask money from this faucet. Okay. We are going to do that to start experimenting with the Ethereum network. Okay. There are many faucets out there. This one is from a service called Alchemy. So it requires you to create an account. It's going to be up there in the right corner. It is free. It doesn't require you anything. And you just paste your wallet address here, and it's going to send you some money. Okay? Sounds like a scam, but no. It's as I said, it's just test money. Educational purposes. I'm going to show so you can experiment with the blockchain. Okay.
But there is a link in the...
Here. You are going to find it. Is the last one. I'm going to show the other links and the other networks as well. Actually, is the third link. Actually, I'm in the wrong place, sorry. It is the first link on faucets, okay? Yeah, and later on you can ask from Arbitrum as well, that we're going to do later. You probably have your wallet address. You go for this website and you paste it there.
Sefolia and then do my other one.
Yeah, let me recapitulate one thing. Hey people, let's recapitulate those 5 minutes. When you create your wallet, unless you are extremely lucky, you are going to have zero balance, right? When connected to the network. How to solve that? Instead of working like normal people, investing money to earn more money, no, we are going to get that for free. So we are going to go for a faucet, for example, Sefolia faucet, and this is going to give us some free money. And later on, we are going to use the same faucet to ask for Arbitrum money. But I'm going to explain the difference before we get there.
We have to create an account with the email that we have, right?
Yeah, if you are blocked from entering, you can create an account. It's for free. Okay, and also there are more faucets, like. So there is one for Infura, there is one that you can mine with your processor, there is one from QuickNode. So you're going to find a lot of faucet options if Alchemy is not working, okay? Any questions in the meantime? All of you using the mobile phones, remember to back up your seed phrases. So tomorrow, when you go in the notebook or laptop, you can use the same wallet. It's asking you to. I'm not a developer. I guess it's going to skip you. Can you skip that? Pick Ethereum, I guess. Yeah, actually you can skip all the onboarding flow. Just. Okay. Oh, good?
Yeah.
You can skip, pick Ethereum. Actually, you can skip the whole flow. Just click on anything. The important is having an account.
Other kind of testnet about Arbitrum, I found only the early testnet.
There is a Sefolia testnet for.
The new one.
I don't know if that new, because Godi is being
I switched from Sefolia network to
Goli.
No, to Arbitrum.
Okay, I'm going to show about Sefolia, about Arbitrum just next. The next thing that I'm going to explain. Oops, sorry. Yes? It's beautiful, isn't it?
Yeah.
Yes, then you paste your address there.
Yeah, I already.
I guess reload and do the captcha again. If everyone is using the same IP, sometimes they block the captcha. It is giving you capture problems. Check if you did not receive. Perhaps you did receive.
Sì, sì, spostano la posta.
Okay. Yeah, I'm just thinking on a problem. We are all on the same IP address, right? So Alchemy is blocking more people asking more money. Let's see. Like if you have access to your cell data, I guess you can request with your own IP, for example. If you have cellular data, for example. It worked. Yeah, but for some people it's not working anymore.
Like for me it's not working. But
yeah.
I wanted to understand. Just like saying me to wait for, like, I don't know.
It worked.
Yeah, but now what can I do with that?
I'm going to show. Okay. Yeah, I saw that something. Let me.
I put my address.
It's giving a captcha error.
No, yeah, I did the captcha.
But it's giving you a captcha error, right?
Okay, but it's
already. I'm going to explain this for everyone. Okay, people. So, let me explain one thing. We are asking this money from Alchemy, and they implement some safeguards against people who are spamming this. So, for example, one of the things that they check is for the IP location that you are asking money. Since everyone is asking money from the same IP location, they are thinking that it's the same person asking a lot of money. See, they are not so smart on that to check the device or whatever. So you can use other networks for that. Or later on at home, you can use the same website to request money from Alchemy as well. Okay? And Alchemy is not the only one that gives free money on those test networks. You can ask from a lot of other providers. For example, in Fura, you can mine with your CPU. You can ask from QuickNode. You can ask from ChainStack.
Maybe between the incognito.
Perhaps, but I guess they're going to see your IP address anyway. But you can use like a VPN and all to request. Okay. So all of you having problems here when clicking here, it is because of the IP block. We are all under the same IP. Okay. Your question? Yeah, we can use a VPN. Yeah, it works. Okay. What? Work? Okay, great. Okay. So eventually, you're going to have test money for proceeding. Okay. Now let's give a look on. Let's give a look in a detail here.
Okay, like it worked with another. I just like hosted my iPhone like Wi-Fi and it worked.
Ah, okay. Okay. So let's dig in deeper now. What is Ethereum? What is that network? By looking at an example here. I just showed a while ago your address, Josh, that it has 0.001 ETH, right? What's your address, right?
My address?
Yeah.
No.
It wasn't yours. It wasn't. It was yours, aren't you, Jordan?
I got 0.
Yeah, but look.
Okay.
This is a thing. If I pick your address again, Jordan, actually, do I have your permission to keep using you as an example?
Yeah.
Okay, because you can deny, of course. We could deny your snack as well, but that's fair. Okay. So if I go to this other website, see, it is already in dark mode. you have 0.0.5 ETH, but you also have 0.0001. Same address, you see? How is that possible? It's the same wallet, different balance. I just told that about 20 minutes ago, remember? Your wallet address is your cryptographic signature that you can sign for transactions where the network, you impersonate that address where the networks agree that you are yourself. It is your identity. And in different networks, Arbitrum, one network. This is the first time we start understanding Arbitrum. And Ethereum is another network. You can have different balances for the same address in two different networks. And when you sign a transaction for one and you send a transaction in one network, it is not going to change your balance in the other networks. Okay? It is your same identity, but you can have different balances, different facades, different materializations in different networks. Okay? This is for all the wallets you have created. Okay? We call them layer 1, layer 0, layer 2, whatever, because they have some systemic links between themselves. You can bridge money in and out. Okay? But I'm going to approach that tomorrow or perhaps Wednesday. Okay? For today, we are going to use Arbitrum as a common network. We can...
Sorry, we have the problem. If you connect with your internet and not with the Wi-Fi, it works.
Yeah, so it is the IP location, you see? Yeah.
Because now I'm rich, so...
Questions?
You told us that the address already exists
Hey people, help me here, sorry.
You told us that every address already exists in a chain. How do you claim ownership of an address?
You just come up with random words, and then you're going to claim ownership of that random address.
Claiming ownership is like a transaction in the chain?
No, you can do that offline. You pick random words, and you compute what is going to be the private key. With that private key, you can...
Oh, okay, I see. What if I use... okay, so I can use random keywords and have the luck to...
Eventually find someone else's, yes.
Wallet.
But the probability is almost zero.
So every wallet exists and every signature exists. Oh, you just pick one.
Yeah.
Okay.
This is the elliptic cryptography. Once you know a point, you know where it goes. But by looking at the destination, you can't go back to the scene. Okay? There are heavy math in that direction. Let's avoid that. But
The generation of the signature was like a transaction, an operation.
Because, yeah,
it already exists like the wallet address.
yeah. Hey people, let's highlight that. When you create a wallet, no one knows. You are doing that anonymously. You in your computer. It's not like Facebook. It's not like Twitter, whatever, that you do a transaction to the web. You do that alone at home. You create a wallet. No one knows, but you now have access to it. Okay. This is the fundamental cornerstone of how the decentralization works. You see? Good question. Things are falling in place, right? Eventually, we are going to build piece by piece until we can build something cool. Okay. So two different networks, the same address, different balances. Okay. Now this introduces Arbitrum, the sponsor of this Urbe Campus. Arbitrum can be linked to Ethereum through bridges, through different interactions that you can do between them. But for today, for this first day, we can use Arbitrum as a network itself, like Sepolia from Ethereum. Okay? And we are going to use a testnet version of Arbitrum, called Arbitrum Sepolia, to transact, to do the smart contract transactions and the experimentations that we are going to do. Okay? You can use Sepolia the same way. They are going to behave exactly equal. The thing is, when we're interacting with someone else, check if they are in the same network. Okay, we are going to do some exercise of sending tokens and such. If you are using in Ethereum Sepolia, the other person is using Arbitrum, you are not going to see the transactions happen.
So with
Okay.
this one we can see the transaction between people.
In every network you can, but here is what I did earlier on with Josh, the 0.001, right? And here is his balance in Sepolia. Okay. 2 different networks. Okay. Josh, right? Jordan.
It's the same.
Sorry. Sorry about this.
No, you can call me Josh because ironically I got an email that is Josh Buta Buta.
Okay. Yeah, I thought I heard this. How to use Arbitrum if you want to do today's lesson in this Arbitrum network as well. Instead of configuring it manually, like some tutorials tell you to do, you can open this link, sepoliaarbscan.io. It is in the document as well, here. And down the bottom, you have this button here. You see? So you add this automatically to your MetaMask. You scroll down. You should have changed it from light mode to dark mode already. Okay? We don't want to attract bugs. So down here, click on this button, add Arbitrum to Sepolia network. Okay? In my situation, it has already been added. And then in the left corner, you are going to have this option here of switching to Arbitrum Sepolia testnet. Okay? That behaves quite the same as the Ethereum Sepolia. Okay? You have a faucet for that as well. Just mentioned a while ago. You can go here and ask Arbitrum Sepolia. Okay? The same thing. You paste your address, you receive the money.
Because these are all like learning places, chats that
Different networks that you can.
chat
Yeah, yeah. Okay. And if you want, you can go and ask for all of those. Okay? It's for free. It's free money on different networks. Why am I explaining that? Because each of those networks is an implementation of Ethereum itself. Ethereum is a blockchain. Ethereum mainnet is a blockchain network, but it's also a protocol that you can mimic, you can fork. Okay? Do you remember the DAO, Ethereum, Ethereum Classic? Like, raise your hand if you know what I'm speaking about.
can you repeat that one?
The DAO. That is Ethereum and that is Ethereum Classic. Okay? Who knows about that? Ethereum and Ethereum Classic.
I don't know.
Okay, but you have heard about this?
Yeah. Like Bitcoin or Bitcoin Cash.
Yeah.
Like this.
Okay. So let's separate this. If you don't know what is the DAO or Ethereum Classic, let's separate the network implementation, okay, that is Ethereum mainnet, that is Ethereum Sepolia, that is Arbitrum Sepolia. Those are implementations, okay, and the protocol itself. Ethereum is implemented in the mainnet, but it's also a protocol that can be implemented in that other networks. Okay, there are a lot of blockchains that are not implementing Ethereum, are not inside the Ethereum ecosystem. Okay, like Bitcoin, like Dogecoin, Litecoin, Solana, Tangle. You're going to see a lot of different blockchain architectures out there. Okay, not all of them remains online 100% of the time, but we can excuse internal joke. But the protocol itself, Ethereum protocol, is what we're going to study today. Okay? The chain that we are using is not important at all. We're going to see the importance of Arbitrum later, we're going to see all of that. But I want to teach you the protocol. I want to teach you that stuff about blocks, about cryptographic hashes, about smart contracts, about transactions, okay? And this is agnostic. It doesn't matter if you are using any of those networks up here. They are all compatible in something called EVM compatible, Ethereum Virtual Machine. We're going to see that later. and you can use them interchangeably. So what is important for us today, it is the Ethereum protocol itself in that document. No, I'm not going to read you all of that. It's just that you know that there is a documentation for this, and we are going to guide you through this introduction today, hands-on, okay? Not reading page by page. Okay? We're about time for the break, or we stand up, we push. Break? Break? 2 minutes?
2 minutes.
No, 10 minutes, 10 minutes, 10 minutes. Okay? Well, 2 hours. Okay. Come back tomorrow. I don't speak so much Italian, so I don't understand some of the things you write. But I trust those are good jokes. That's the spirit. You visit Brazil, I'll give you some Portuguese jokes as well. So, now we are going to understand Ethereum network, Ethereum protocol as it is. But before we get to the point of Ethereum and smart contracts, let's consolidate this thing about blockchain networks. We can do those transactions. We can actually, first of all, before doing transactions, we can check all balances. So, Jordan, I have checked your balance. You now, for example, you can send money, you can sign a transaction for sending money for, let's say, the next in line for Annie. Sorry if I misspell her name. And Annie, now you can send for Gabriele, that you can send for Michele. You all are able to transact in those networks already. Okay? So, if I ask now, what is blockchain for you? Now you can give a simple answer. If you never heard about blockchain, now you can answer something like, hey, it's a place that I can hold assets, that I can randomly encounter all the people wallets. That's a technical detail, you don't need to mention that. It's a place that you can send transactions like a bank account, right? That makes more sense now. This is something that was possible since Bitcoin. A paper that said nothing about blockchain. There is no word blockchain in that paper. It was electronic peer-to-peer cash payment system, something like this. Proposed in a cyberpunk forum for a person called Satoshi Nakamoto, a group of person called Satoshi Nakamoto proposed that paper that was a system for people to connect to that protocol called Bitcoin to transact those tokens between themselves. Before the Bitcoin project, people tried DigiGold, DigiCash actually, BitGold, a lot of other protocols that try to do the same thing, cash systems, decentralized cash systems to transact value, and failed. The first one to succeed and to be living until today, it is Bitcoin. That can't be shut down because of that architecture. You just saw that. Now you can answer any expert out there how Bitcoin is unkillable. You cannot shut it down because you cannot prevent people from creating accounts. You cannot prevent people from signing transactions and broadcasting to the network, okay? Because it is a protocol. You don't kill a protocol. You kill the implementation, okay? I don't know if that is crystal clear yet, but you are now seeing the truth, the basics of what make a blockchain a decentralized place. And this is enough, for example, to stop fake news, fake information for that. You now know the essence of making a blockchain decentralized. But this doesn't explain what we need about Ethereum yet. Because we are speaking about transactions, asset transactions, that is data, my balance in my bank account, $6. Not kidding, that's my balance right at the moment. I'm working to improve that. It is a piece of data, number 6. We are going to see more of that, more than just changing a number. Because if we are speaking about sending just money, like Bitcoin do, let me show here at Sepolia Etherscan a list of transactions. Okay, view all transactions. It's a feature from this application. There is a lot of people using that network. Okay? Those transactions, they get bundled inside blocks. So you don't process transaction by transaction. You bundle 100, 200 together, 50 together, and process them all at once. Okay? Just for network efficiency. And they are transacting assets. For example, the transaction I did a while ago for George, actually it was in Jordan. It was that transaction. Josh or Jordan? How are you?
No. Call me as you want.
Okay. I'll call you Bob. So this is one transaction. Okay. It was bundled inside a block with a lot of other transactions. Okay. And it went through, it was included in the blockchain. Okay. When we say included in the blockchain, the actual explanation for what is happening here is that it changes the state of the blockchain, a shared state. What is the temperature in Rome today? So it is information, it is a state. You can check it according to some source. You can have consensus about that or no. Some people can say that it's 40, some people can say that it's 60, depending on how you measure. Okay? For a blockchain, there is no doubt about a state. It was 0 before. After it went from 0.0001, and everyone's agree on that. That's something called consensus. That is the state of the blockchain changing. Okay? This is what a transaction do. And this is not only about blockchain, this is about transaction. If you get the definition of transaction in mathematics, in whatever, you're going to see that it's something that brings a state from before to after. Okay? Have you ever heard about state machines? Raise your hand. State machine. Like a washing machine. Okay? You can either wash or dry. You cannot have those two happening at the same moment. Okay? And you put your white t-shirt there. You forget one red sock there. You put it to wash with the bleach, and eventually you have a pink t-shirt now. Okay? So the state changes. You don't have a soft transition. Was white, and then was pink, like a parallel, okay? A state machine. It is a concept from a lot of algorithms and programs use state machine, okay? It changed from before being 0, after it is 1. What changed that is a transaction, okay? This is a blockchain transaction, but this is the same word transaction that you would find in other places that you are studying it. If we look at this list of transactions here, you are going to see some people transacting money around. And there are some people transacting 0 money. And one thing more funny about that is that all of those transactions, they need to pay a fee. We're going to explain that a little more later. But since it is a decentralized network, you can't convince people so easily to work for you for free. Okay? When you are using a Web2 product like Facebook, Twitter, your bank account, whatever, there is someone paying for your transaction. Okay? A centralized server or whatever. In a decentralized network, there is not this kind of thing. So you need to pay yourself. You need to pay for your own transaction. Okay? To convince someone to do this computational work for you. We're going to see more of that in the future. So all of those transactions here, they are paying those fees to send 0 money. Imagine, you go for your bank account, your bank branch, you call your manager, hey, I have a special transaction to do today. And then the manager is all happy, a lot of money flowing in, is going to earn a good fee. And then you ask, manager, I want to send $0. It doesn't make sense. You are right, you are sending a message. You could write a message in the back of the check and send $0, but it doesn't make so much sense, right? Yet, here it is. What they're doing, are they spamming the network? Like they are clogging the network with $0 transactions? What they are doing here? These people is the difference from Bitcoin, 2008, 2009 until 2015. It was only used for transacting one kind of data, that is balance. My balance, how much Bitcoin I have, how much Bitcoin I can spend, how much I have sent you, how much you have, how much you can send, this kind of data. Money, my balance, amount of money is a data, right? So this information is there in a shared database. This is what Bitcoin and other blockchains did before the invention of smart contracts. Okay? A guy called Vitalik Buterin, almost a kid at the time, and some other people like Gavin Wood, Joe Lubin, they thought on this ecosystem that you would transact other kind of data inside the blockchain as well. It was first proposed as an implementation for Bitcoin, okay? But the people that the community didn't like at the time, so they created another blockchain for that. And these kind of transactions that are called smart contract transactions, let's pick a random one here, for example, this call here. They are transacting zero value. They are sending zero value around. They are not transacting money. The data that they are changing is not money itself. Okay? They do pay a fee, so they update those balances as well. But the most important thing that is happening here, it is not the zero money transfer. No. They are sending some data. Let me show you that. They are putting a hidden message in the input data 0xBE9A6555. I just found that transaction out there random. And this input data, when I send that for the blockchain, this doesn't work in Bitcoin, the original Bitcoin. It works only on Ethereum and other smart contract enabled blockchains. This data is processed inside the transaction in a special place called Ethereum virtual machine, a virtual machine there, that is able to calculate outputs. So if you look at the state, we have this money transfer here as well because of the fees being paid. But also, we have a storage database place like that we change things. So we changed this number from 1 to 0. We changed this, let's say, address here to 0. And we changed this number from here to 1. This is a program being executed inside the blockchain. This is not just money being transferred. It's not like I have 5, I send 001 to Jordan, Josh, and Bob. It is a computation being carried out. Could be a game, could be a voting machine, could be a social media post, could be a lottery, could be a DAO governance, could be a complex trade being done, a calculation if it is my birthday, could be an image generation on chain, could be a lot of computation being done. Because the introduction that Vitalik did into the blockchain is to enable a Turing complete virtual machine that is able to compute outputs depending on the input that you put in a message. This is what smart contracts enables us to do. Okay? You don't need to worry with the technicalities right now. Just imagine that now you have a computer running on top of the blockchain. 5 minutes ago, blockchain is what? A place that I can send transactions. That is true for Bitcoin. Okay? But now we are seeing that a blockchain is a place that we can transact any kind of data. Verifiable data, verifiable computation. Going back to that transaction, we see that the input data is 0x. So it didn't compute anything. It's not a game, it's not a voting, it's nothing. It's just a simple transaction that I paid a fee for that. So the state changing from this is my balance decreased, Jordan's balance increased. Let me pick another transaction here in Sequoia that it's going to have more information. For example, this transfer here, okay? So the state changes in a transfer. One person balance decreased. For example, a person is sending 2 ETH. So this balance increased by 2. This balance decreased by 2 plus some things. And another person received this. Whenever you have a transfer, you have 3 transactions, okay? In Arbitrum it's different, but in normal computation you have this. A person receiving the fees, a person paying the principal and the fees, and a person receiving the amount. This is true as well for those smart contract transactions. You also, what was the transaction? I used this one. You also have the person that produced the block receiving the fees. This is always going to have. So even if you send 0 money, you still pay for the fee. So you still update the balance. You lose a little of money. But you also have data being computed here. And what governs the data being computed? How this output was reached from this input? What sits in the middle? How come that everyone agrees that when I say BE9A6555 to the blockchain, that output happens? What determines that? That everyone can agree that this is the output from saying that. Now we finally get there. This is the job of the smart contract. These people, this is a smart contract. Beautiful, isn't it? I could print it and put it in my wall. Because this is immutable, it is stored in the blockchain. Everyone can see. Everyone can compute. Hey, when I say ABC123 here, what is going to be the output? This is a code. I can compute this code inside the virtual machine of EVM, and for the same input, it is 100% time going to give the same output. So anyone can verify this computation. The leap is short, but I know it increases a lot the complexity. The same way that anyone can compute and verify a transfer, like a bank transfer, like I send you 0.001, anyone can now verify that the output of this program running the blockchain is that, given the same input. So it is my birthday today. I make a program for that. Based on all the inputs, we're going to have output. 1st of January, false. 2nd of January, false. I can do this program. 365 lines of code, right? Or I can write in just 2, because some party going on. Because there are better ways to write this program. So this program is uploaded to the blockchain, held there, and anyone can testify the output. So it doesn't matter who executes the program. Okay? If I make a program to say, if you guess my birthday, I give you $1 million. I'm going to make that program. And then you run in your machine. It's easy to cheat. You change the byte of that program. You just have one attempt, okay, to make it fair. Because eventually you were going to get it right in 366 attempts, right? Because of leap years. So this program, you can only run it once. It would be easy to cheat. You change the bytes of the program, you say any date, and then you get $1 million. This is inside your computer, right? What's the trick here? This code is uploaded to the blockchain. You see? So even if you cheat, you can cheat. Everyone is going to see that you cheated. They cannot prevent you from cheating, but it's going to be crystal clear that you execute a computation that does not come from that smart contract, from that code. Okay? So this gives security, this gives immutability for whatever you are processing inside that blockchain. Makes more sense now? This can't be achieved with normal programs. You can even put that inside a chip, a protected chip without access to memory, whatever, but you can always somehow compromise it. If it is your own device, you can compromise the input, the output, the temperature, you can physically compromise the chip. If there is enough money involved, you can have incentives for doing that. In a blockchain ecosystem, no. Since this smart contract code is uploaded to the blockchain, it is impossible to cheat it. So you can use it for computing money-sensitive tasks without having the counterparty risk. If this was a social media, for example, program of a social media. Social medias are a program, right? Meta, create Facebook, is a program running in the servers. So if you say something bad, let's say you post a picture of a pizza with ketchup, okay? They are able to ban you. Rightfully, okay? In Brazil we do that, okay? Don't blame me. It's common, but I know in Italy you should not do that. So you are subjected to the control of those central parties. In Web 2, that is normal. In your bank account, you can wake up someday and you have $0 because you did something or someone persecuted you or confiscated your money. That is possible. You see that with this, you are safe. If this is Facebook on chain, like Lens, Farcaster, whatever, you can't be blocked from what you say. Yes, you can post a picture of pizza with ketchup and no one is able to take it down because the computation is done inside the smart contract. No one can change that. Okay? No one can change your balance. No one can hack you. You are there, you are safe. This is the invention of Ethereum, of smart contracts. And all the smart contract blockchains operate in similar premises. Okay? Starting to make more sense now? Question?
I know this is like a dystopian case, but what if every computer that participates in the chain decides that a block should change? Like,
In the same moment.
it's possible? I know that sounds like dystopic because there are millions of computers maybe running in chain, but what if every computer gets hacked and now the hacker wants to change a block on every computer that participates?
Yeah. They can. But they cannot convince you.
Yeah, of course.
So you are going to be alone, the own bastion of the truth, and everyone else is going to be wrong. But even though people can agree with you and leave the other chain and keep using your chain.
Because what if I'm the only one not touched by this great hacker and I have the old original version of the chain?
It is sad, but it's true. Yeah. This is what I was explaining, the difference from the implementation to the protocol. Remember, this is the Ethereum protocol, but the implementation is on each node. So what happens at the DAO? There was a hack, okay? And then the community stepped in and they said, hey, the hack happened, the information is true. The hack happened and the information is true. But what if we pretend that the information is false? That the hack never happened. And then they lied on chain. And this created two groups of people. People that was telling the truth, the hack happened, and people that were telling a lie, the hack didn't happen. Okay? So this created a chasm in the blockchain. That is Ethereum Classic, and that is Ethereum nowadays. And Ethereum, the majority of the community, accepted to live in a blockchain that has a lie. Okay, I'm not saying that it was wrong, not saying that it was right as well. Don't have opinions on that. It's just that they changed the state, you see. They are pushing a lie on chain by doing a fork that is now Ethereum. Ethereum Classic still exists, but only a few people use it. Don't have the same value. But it is truthful. The hack happened. Okay? You see, people, that sometimes you get with immorals, ethics. A hacker should be kept on chain after it hacks someone. So Who is the judge to say that? This is more, this is ethics. Has nothing to do with engineering. I'm teaching about engineering things. I'm not going to enter the ethics or morals of that. But the truth is, a hack happened. And they changed that, for good or for bad. See, they changed. And this is a break in the blockchain. You have Ethereum, you have Ethereum Classics. Okay? This is good to understand because consensus, everyone believing in the same information, everyone believing that this is the smart contract, and this is the state produced after. So it was before this and after this. Consensus is everyone believing that this byte is 0. And it's crucial for the blockchain to exist. If you have different opinions, hey, I guess this byte is 1. No, I guess it is 0. No, I guess it is 2. So the blockchain doesn't work. You need to have consensus. Everyone needs to believe the same thing. And this is how the system is designed to be. Okay? If you have room for like morals or ethics or whatever that is subjective, then it doesn't work. Okay? It needs to be 0 or 1 for it to work. Okay? This is for the implementations. It is very confusing, I know, but I'm trying to focus more on the protocol now. The protocol is like this. The implementation needs to have consensus. On the protocol side, a smart contract, it is a place, a piece of code that we can compute the output based on an input. Okay? That is living on chain. You can even execute this EVM standalone. For example, Sputnik EVM. It is a Rust-made EVM that you can run to interpret code in your machine outside of the blockchain. Why? Because, I don't know, you want to do a calculator, you want to do whatever. It is a program that you install in your computer, you run, you give it inputs, it's going to give you outputs. Okay? A standalone is just that. It's a virtual machine that you can have outputs based in the input. The power of it to Ethereum is that when you put that inside a blockchain, like this transaction, executing that smart contract, you can have a program, a computation that is immutable, unbreakable. Okay? Good. The consensus part is about the implementation. We are speaking more about the protocol now. So let me show you an example of that, so you have less chances of forgetting this. So let's head to this application here called app.uniswap.org swap. Okay? And for that to work, we are going to need to connect to Ethereum Sepolia. Okay? It doesn't work in Arbitrum Sepolia yet. If you do connect in Arbitrum, you are going to have this error message here in the left. Okay? Actually, what is going to happen to you when you enter is that you are going to have this connect button. Now, if you connect with MetaMask, connected to the Arbitrum network, is going to give you this warning. To fix that, I'm going to change for Sepolia network. Okay, now I'm connected. Let me change the account here. I want to change the account 1. Okay, it's right now. So you enter this app.uniswap.org, you connect your account, and then you select the Sepolia network here for it to work. Okay, Ethereum Sepolia, not mainnet. This app, this is an example of a D-app, decentralized application. This app, it's able to run a program, run a computation for us, using smart contracts that are hosted, that are uploaded, that are verifiable in the blockchain. It's not going to run in a central server, no. This app is an app able to exchange currencies, okay? Let's say I have $1, I want to change for euro. 0.995 euro, something like this. How would you do that? Or let's say you're traveling to America or to any other country, you want to exchange money. How you usually do that in your daily lives? You don't travel a lot. You travel. Let's say you're going to travel abroad and you need to exchange currencies. How usually you do?
Yeah, I go maybe to a bank, I exchange, they make me pay commissions and stuff.
Okay,
Or I can
and they charge you. You usually do it with paper or you do in an app?
both.
Okay, so you have done in app. Okay. Have you ever used the app for someone else? Okay. What they do, they operate this business, a business with persons, that they buy a currency, sell to another person, earn a spread, need to be profitable, otherwise it's going to go bankrupt. Okay. A business, company. You can name a few. Like you usually exchange in what bank or what app you use? Unicred.
Yeah.
That is wise. That is a lot of. You can do that with PayPal. Okay.
Yeah.
This is a service, money exchange. Okay, rings a bell for everyone. Usually businesses do that. Okay, and they have applications to do that. You go to the app, you choose your currency, your currency from, your currency to, and they exchange that for a rate and they charge you something. Okay, is that clear for everyone that this is an application? It can be developed, it can be put there, it can be profitable. This is the same thing. We are going to exchange here ETH, that is in my possession, to another currency. For example, this other token here called Uniswap, the Uni token. Okay. Let me put an amount here. I'm going to exchange 0.001 ETH. Let's see, it's not working. Why not? 0.1. It's not fetching the price. That's unexpected. Okay.
Because the balance of Uni is too little.
Should be calculated that. Okay, let's pick another token. Rapid ETH. It's not so funny because it's always one-to-one, but at least it works. You can try and find other tokens as well. Usually it works with Uni. Yeah, that's sad. Let me just search for another token, Sepolia might. Yeah, it's not working. Okay. Need you? Okay. I guess it is in my wallet connection because it shows 0. It's not working?
I think so, yeah.
Okay. Let's do it rapid ETH then. It's going to be the same example. Okay. So, an application that is not behaving so well today, nasty Uniswap, but it's going to behave with those two tokens, ETH and rapid ETH. Those are two different tokens. They are always pegged 1-to-1 because rapid ETH is just a packaged version, a rapid version of one ETH. So you can always wrap and unwrap. Okay? It has a purpose. It's not that useless as it seems. But it is a conversion, okay? just 1 to 1. Let's say the United States dollar is costing exactly €1. So you can swap 1 to 1, okay? Sometimes it happens. So this is going to be the same thing, a swap operation changing 1 for 1, okay? We are going to execute that transaction by clicking on wrap, and it's going to send a transaction to the blockchain. It is not going to be operated by a backend. There is no company here. Uniswap is a company, they developed that, but they push it to the blockchain. Even if they go bankrupt, even if they cease to exist, still this application is going to work. It's not operated by them, it's not maintained by them. How? Because they pushed the code on chain already. Remember I showed you the smart contracts? They pushed that already. So when you click confirm here, you are going to send a transaction directly to the blockchain. Let me pick that transaction here. Yep. I can click on view on block explorer. It is pending. It wasn't included in a block yet. I have sent that transaction for the network, but no one decided to include it in a block yet. So it is not through yet. It's not part of the state. Could revert, could fail, could vanish. Okay? It is going to be part of the state when it is accepted into the blockchain. Okay? It's taking a while to confirm. I'm going to explain another thing in the meantime. Remember that we pay a fee for those transactions. No one's going to work for us for free, right? But there is another thing. There are only so many people willing to do this computation. It's open for anyone to access, but not everyone is doing that. Depending on the incentives, more people, less people are going to show up to do that. So there is a market for computation. You are competing for block space. You can only include 200, 300, sometimes 100 transactions in a block. It doesn't fit so many transactions. So what happens when there are more people willing to use the blockchain? There is block space. Then there is a space available in blocks. What happens? Some people get sidelined. Hey, you wait a little more. It is what is happening here. Our transaction is waiting.
The slot that you compete to get is competing by the company that has the transaction, or
by everyone. So a lot of people is trying to mine this block, trying to propose this block, depending on the consensus mechanism, and they can only fit so many. So it's natural that they are going to select who pays more. It's like you are in a big party and there are like 5 bathrooms only. And you have a big line of people you trying to use the bathroom at the same time. And they are competing each other. Hey, I pay $5. No, I pay 10. No, I pay 100. I want to use it now. No, I pay just $1. I can wait. They are competing. Who gets first? And the block space, the amount of things you can put in a block, is determined by the protocol. So you cannot create block space out of thin air. Okay? So it is a fixed demand. The more you pay, the more probable that you're going to be picked next. Okay.
The block processing progress is progressive, like linear, like one block and then another, or like parallel, like a bunch of blocks together. And if it's in parallel, and the state of the machine is established, can my state be different? Like I send 2 different translation in different moments. One, I have only 1 Ethereum, and I send 1 translation transaction from 0.5, and another of 1 Ethereum. And like playing with the fee, I hoping that 2 people elaborate 2 different blocks with 1 translation and 1 other translation. So my state will be 0, but I send 1.5.
So you wouldn't have consensus. How much you have? You have 0.5 or 0? So, or minus 0.5, right? It depends. So this is what they call blockchain. There are other designs like block lattice, DAGs, but in blockchains like Bitcoin, like Ethereum, you can only have one block at a time. Yeah. It sometimes happens to have siblings and uncle blocks that are proposed by the same they would be proposed to the same place by different people. Because of some network conditions, sometimes it happens, okay? When it happens, you can have an orphan block that is sad. You have a confirmed transaction, but no one believes in that. Or you could have a reorganization that the network eventually put the right blocks at the right place. Okay? So then your block get picked and your transaction get ordered. Who is going to determine first or last? It is the order of transaction that you sent. If you send the transaction first 0.5 and then 1, the first one is going to be processed first. Okay? To be 100% honest, you can tamper with that. You can choose your transaction number as well. But that's not going to allow you to hack the blockchain as well. Because the first one to be included is going to deny the second one. Okay. And then the blockchain solves that. In no situation you have a double spend. That is this case you mentioned. Okay. And it's completed. Your transaction was included. In this block we have 22 block confirmations. So at this point we can be quite sure that there's not going to be any reorg or any orphan blocks or whatever, because a lot of people have confirmed this transaction and it happened. It is a smart contract transaction. A lot of blocks, 22 block confirmations. So unless one person confirmed more blocks, we have 22 attestations that our transaction is completed and it's good. Okay.
But people like us?
Yeah, different computers confirming those blocks. Okay. This you are asking, it is something called finality. The finality of the state. When we know that the state is true, it is unquestionable. Okay. This is another talk. The short answer is never. But actually, the more confirmations you have, the safer you have that the finality is there.
But there is a limit of block confirmations, or
yeah,
independent by the system.
Now, the most confirmations you can have in a block is 5 billions, 500. Okay, so the amount of blocks that happen. That is the confirmation that the Genesis block has. But nothing is going to stop people from pushing your blocks. It's never going to have a limit in the future. Okay. This, people, is a smart contract transaction. We called it for executing an operation for us. Instead of going for Western Bank or Wise or PayPal, we called that smart contract with those bytes. Each couple of hexadecimal characters forms a byte. So this is 1, 2, 3, 4 bytes that when sent for that specific smart contract, so when you send specifically those 4 bytes, specifically for that smart contract, it gets combined like a chemical reaction inside the EVM. The EVM is the catalyst. You have outputs. You have computed outputs inside something like a database that calculates the state change. So this number, imagine this like a database, people. This number at this storage address was 0. But after I send those specific bytes to that specific place in that specific way, now I have this number. Okay, because of decimals here, it is a big number. I'm going to explain that later. This is a smart contract. Okay. This is a piece of code hosted in the blockchain that when I send the specific inputs in the specific configuration, it is going to give this output. And everyone can validate it. Everyone can go execute that again and say, okay, you are right, you did not cheat. And then the next one, and then the next one, the next one. You never trust. you always verify. Okay? Questions? This is a smart contract.
Yeah, but like, I mean, like the system seems like pretty secure, you know. Like, how can people cheat on this? Like, cheat about like transitions?
You can't. You can go on with a lie. Okay. Even if you produce a false block, somehow you get away to produce a false block. Your sheet is only going to last one confirmation, because the next person to compute your block is going to say, "Hey, this is wrong." Okay. So there is a mechanism for producing blocks that involve money. You have to stake money and have to spend resources. That even if you cheat, if you spend a lot of resources to tell a lie, my balance is 2 instead of 1, the next person is going to verify that this is false. Okay. So this is a safe computation. This is like an internet computer that no one can tamper with. If you try to do that without blockchain, let's say in torrent, you distribute a program through torrent. You know torrent protocol? Like peer-to-peer file share. Through Drive, Google Drive, okay? You could be prone to someone putting a virus, changing the computation, okay? So there is no other way known by humanity to run things decentralized. The only way that people know how to run computation in a decentralized manner as it is today is using this system of blockchain. This enabled humanity to do this. Without coordination, without knowing each other, we can know for quite sure that the program is running correctly without any fault, without any possibility for being attacked or being subverted. Okay? These are smart contracts. Let's build our own smart contracts. Are you excited? So, about 2 hours deep in explanation, we finally start to program smart contracts. Okay? We still have time for questions if you want. Yeah.
So why I don't see the WF inside my wallet? I did this work, but I didn't see the.
Like you don't have it inside tokens here.
Yeah.
If you it's not here. Okay. There is a way to add. You can say for sure that you have it, okay, because it's a public information. So the balance of urbe.eth is a public information. You can pick your address. And my situation here is this. And you can always read information from the contract, okay, regardless of your MetaMask. So if your first concern is, I don't know if I was scammed or not, you can always read this directly to the blockchain. Okay, it's quite simple to do. I'm going to connect it here just to show you that the information is into the blockchain. Okay, there is this call that I can put any address and carry the information. It answered for me. Okay, so even without MetaMask, it is true into the blockchain that I have this balance. Anyone can come here and check. Even without Etherscan as well, okay? If I go directly to a node, I can make the same question, it's going to answer this number, okay? But now you might be asking, hey, what about MetaMask? I want to see it inside MetaMask. So you can click here on import tokens, and you paste the contract address for Rapid Ethereum, okay? You can pick it here into the Etherscan. So now that I have added it, I can see that I have this balance of Rapid Ethereum, okay? By the end of today's lesson or tomorrow, we are going to see what is a token, what is a smart contract of a token, if we have the time. But for now, just consider that the information is there, is saved, okay? It is stored. So to build a smart contract, what we need to do is to, where it is, code. So what we need to do is to write all of those bytes. Okay, all of those bytes. So what we are going to do, we're going to open Notepad and start by writing the bytes ourselves, right? And we are going to memorize. So 60, 60, 60, 40, it is an operation for opening an account inside the EVM, okay? Memorize that. Now 52604, it is the address of where you want to put that information stored. You're writing it down, right? So, yeah. This is not how we write smart contracts, sure. Unless if you are a robot. Okay? I do have some online bootcamps, and I'm starting to think of the possibility of some AI students watching my bootcamps. Here is more difficult, unless you are like androids or whatever. I trust you more than my online students, it seems. Unless you are a robot, this is now not how you write smart contracts, okay? You could. If you have a lot of free time, you could write a smart contract with just bytecodes. It's like programming in assembly or whatever. But there is a much easier way to do that. We can use an IDE that has a program called compiler inside of it, that you can write human-readable code on high-level languages like C, like Java, not PHP. Or Solidity. You can write smart contracts using Solidity, a very customized language built for building smart contracts into the Ethereum ecosystem. Okay, let me close some of those tabs here. Not this one. And instead of writing this like a robot, bytecode by bytecode, I want to invite you to use this IDE here called Remix. Okay. Okay, what is that? That's new. Okay, whatever. So, this is the application called Remix. It is an IDE, a development environment, that you can use for coding, managing your smart contracts, compiling, debugging, and executing them on chain. Like full stack. We are going to use this today, tomorrow. Today only, and tomorrow we are going to switch for another programming experience, but this is a good starter because it doesn't require you to install anything. Okay, so tomorrow we use a little of that and we move to another, and today we are going to keep using Remix until the end of today's lesson. In this IDE, when you open that, just click on that link, answer that survey. You are going to be presented with the File Explorer, where you can manage your workspaces. For example, here, I have opened this workspace that I had using in my machine, but you can create a new one. You can click on Create a New Workspace. You can start with some templates. So let's pick like a basic, and this is going to be Urbe Campus. Okay. And this is it. I have a new workspace, a new project that I can work on to manage my files, edit those smart contracts. I can later on compile those, I can run those, I can debug. Okay? It's a quick start for blockchain development. So when you enter Remix, or when you create a new workspace with a basic template, you are going to see this folder here called contracts. And you have those 3 sample contracts inside. Let's pick the first one, storage. Let me just do one thing real quick. Okay, storage. Okay, so let me redo this. No, doesn't matter. We're not going to have those 2 folders, okay? Don't worry about this. So when I click on storage.sol, this is human readable code. Those are characters that can read. Title, storage, dev, so are not just bytes, not zeros and ones, not just hexadecimal, okay? It is still a program language, okay? There is no natural language programming like hey, GPT, make me a contract that swaps currency. A lot of a lot of types. But this natural language processing is not available yet for programming smart contracts. No one invented that yet. And if you try asking that for ChatGPT, it's going to answer you wrong most of the times. We are trying to fix that, but this is it. So you don't use natural language, but you don't need to use low-level language as well. You can use solidity. This is the syntax of a solidity smart contract. All of the documentation links for you to understand what is going there are here. You can read this at home. Later on, you can follow some of the keywords that we're going to be presenting today. But if you have a small background on JavaScript or Python, this is going to look quite familiar. Okay? Raise your hand if you have zero development background, like you never coded. Okay, 1, 2, 3, 4. You can raise your hand, people, if you never coded. It's good because for you, I'm going to explain things like creating variables, function calls. Okay. So 4 people only. That's good. A lot of people have you. For all of you that coded, what languages like you coded before? C? Everyone C? C? Python? Okay. Yeah, but I'm asking people because like if you know what is a variable, if you know what is a function, a class, okay, I don't need to explain those things again. So all of those languages, C, JavaScript, Python, they have those primitives, so I don't need to go on those basics. The thing is, no matter what language you have used in the past, there are some peculiarities, some specifics of blockchain that mixes some concepts, like storage and databases with variables in the code. So it's going to be quite confusing for everyone, no matter what background you have, okay? It's not the best thing to cheer up your mood, but it's like do a few steps back to understand some of these concepts, okay? What we are used to do in programming, like we write hello world, and then we execute in console, and it's output something. Right? Have you ever written a hello world in your life? First thing you do, right? When you program. For blockchain, it's a little different. We don't have executions in a console. Okay? Like you don't execute in your machine a smart contract. Okay? Can you understand that? Like a while ago, we saw that when we write a smart contract, we upload it to the blockchain. Remember? It is there for everyone to call. And we can't execute the whole code. It's not an executable in the blockchain. What we do for triggering execution in a smart contract, we did it twice already. You send a transaction. Okay. You all got that? You can't click on run a smart contract. There's no entry point. The only way to trigger an execution of a smart contract is when you send a transaction. Okay? So a smart contract is much more like a vending machine than it is a program. Why a vending machine? Like there is even this example here in the documentation. Smart contract. Okay. So a vending machine is like that. You put money, and then you choose a snack. Your snack is dispensed. You don't go for the vending machine and say, "Hey, vending machine, execute." It's not like a Discord that you open, a browser that you open, and it's there. So it's not a program. Yeah.
If you cannot run it, how do you debug it? How do you debug it?
You don't. It's very difficult to debug a smart contract. Console log. You do console log and then go for it and exit. I'm going to show that. I've designed this bootcamp because this is a pain for us when we develop projects as well for people. So I've designed this bootcamp for giving you dev tooling that allow you to run scripts and test smart contracts. But most of the people don't. When you do this, you have an edge in hackathons instantly against your competitor that are not doing. So I'm going to suggest you some ways to do that. But you can see already that if you can't execute, it's very difficult to debug, because actually you can't debug a smart contract. A smart contract is only going to run when you execute a transaction, and more.
When you see the output, if it's wrong, it means there's something that...
Yeah, and then you can test an output. But this is the pain. You have to give it a lot of inputs and see how it reacts. So let's test the whole thing. It takes a billion years. Yeah, and it depends on the address that is calling it, depends on what sequence it is being executed, you see. It is a mess. So you can see it that far. It is very difficult to debug a smart contract, indeed. Because a smart contract is not like a program that you execute from beginning to end. It is more like an add-on, a vending machine that is going to react some ways depending on how you call it. Okay? So going back here to our smart contract, when we are coding a smart contract, we do something that is similar to an object on line 10. That is the definition of a contract. Okay? It is a lot of things to remember. I don't expect you to remember everything on the top of your head. The most important thing is to remember where to look for that into the documentation. So for example, what is the layout of a Solidity source file? So the first thing you need to put is this, an SPDX license identifier. Where is that? It is the first line here. I'm going to go through this with you patiently, but what I'm trying to say is that you don't need to remember that in the top of your head. If you don't remember something and you Google out, you find the documentation, it's great. Okay? It is even advisable because those things change a lot. They could release a new version of Solidity that the first line is your whatever identifier, is not your SPDX license identifier. So if you go for the documentation, you can keep yourself updated instead of just trusting what you remember. Okay? This is why I don't use the slides as well for teaching. I teach with the documentation. Because when you do a slide for a blockchain course, 6 months from now it's obsolete. A lot of things are going to be wrong. So go for the documentation, get acquainted with it. When studying a smart contract compiled with Solidity, for example, the definition of this contract, storage, is part of the structure of a contract. That you can have state variables, functions, modifiers, events, errors, and all of that. You can declare contracts, you can declare libraries, and you can declare interfaces. All of that. What if I forget about this? Then that is the language grammar. For example, when we are initializing a smart contract, you have pragma and then you have pragma token. Yeah, pragma, Solidity. I'm going to show you guys what is this. So I can have an import, I can have using, I have a contract definition. How to do a contract definition? So this is the way. I can put the word abstract or not. So I could come here and put the word abstract. Okay, that is possible. Or I could skip that. Those two ways are possible according to the grammar. Then I need the word contract, exactly like that. Can't be capital C, can't be all caps. It needs to be exactly contract. If I change one thing, it doesn't work anymore. And then I can pick an identifier. It can be any word except the reserved words. For example, I'm going to create a contract Solidity. No, it doesn't work. Okay, contract uint. It doesn't work. Those are reserved words. Contract contract. You know what I'm saying, okay? So identify can be any words, but the reserved words, okay? So everything, this is just an example. Everything that I'm going to be saying here, if you forget in the future, you can find in the grammar. You just need to learn how to read those charts, okay? So whenever you have this, is a branching, it is optional. Whenever you have this rounded, you need to be exactly like that. Whenever you have a box, you are free to implement what the box says, okay? I'm going to show a few examples of that. So this is a Solidity smart contract. Before we get into the details of the syntax, let me explain a very important thing. The contract itself, the Solidity contract, those lines of code, 1, 3, 10, 12, they are not going to be uploaded to the blockchain. Okay? You don't have readable Solidity code uploaded to the blockchain. What gets uploaded to the blockchain, it is the compiled output. So you have inside this IDE the Solidity compiler. Okay? There are a lot of different versions of compilers that you can use. Most recent is 0.8.24. Okay? 0.8.24. 0 means that it is in beta version. How many billions runs in Ethereum? Let's check. $66 billion, give or take, in something that is in beta version. Not all is written in Solidity, but the other languages are even worse than that. So when you use this compiler that is in beta version, you can create those smart contracts by producing bytecode. Let's click on compile. Compiled. Did you click? Click. You're going to compile your first smart contract in your life. It's a memorable moment. Perhaps. I don't know if you have ever done that. And then you can copy this bytecode by clicking down here. We open Notepad. And this is the bytecode for our contract. Where is the Solidity? Actually, this bytecode could be compiled with anything. Could be compiled with Python using Viper. Could be compiled with Rust. Could be written byte by byte like a machine. Okay. The compiler bytecode is a product from the Solidity source file and the compiler. It is not an output. Okay. You can turn an orange in orange juice, but you can't turn orange juice in orange directly. If you reverse it through the blender, like it doesn't work like this. You can know that it was an orange, but you can't know exactly how the orange was before. So this is the same thing with this bytecode, okay? It is important to highlight that because it is very common to mistake, to confuse the things that we are doing inside Solidity to the things that are happening into the blockchain, okay? For example, a very common confusion. Remember, we have this Rapid Ethereum smart contract. Let me remove the zoom here. See, we can find the source code here. The contract is here, right? So what if I copy the contract? If I copy this, put and remix, and change a line. Oh my God. So let's change this for 19. Did I hack Rapid Ethereum? I'm going to deploy that to the blockchain later. see, this is the thing. Let's separate the contract code, solidity, that is the source code, that when I put the source code into the compiler, it becomes bytecode, and when I deploy the bytecode, it becomes a contract, okay? Let's separate this, the contract, to the instance. Because when you change the code of the contract, the source code, the solidity code, you are not changing the instances of the contract, okay? Remember that. This is different. The instance of a contract is different from the source code.
But what if you somebody else did change the same number, like from 18 to 19, and you publish this contract, like the same version?
Yeah, this is the thing. You publish to GitHub, you deploy again, and all. It is very common to confuse, to mistake the new published version with the old instance. The old instance is still going to be there, you see? Later on, we're going to explain inheritance. We're going to explain the interfaces, that is one code changing the other, and this confusion keeps returning. So from now, be prepared, be prevented from this. If we change the code of a Solidity smart contract, we are not changing the implementation data. We're not changing the functioning of a smart contract already deployed, okay? So let's go back here. This is also Solidity file. So when it's compiled, it becomes bytecode. When it becomes bytecode, we can later on deploy. Okay? A quick tip, turn on autocompile, and every time you make a change to the contract, it's going to be compiled again, so you don't need to hit that button. This contract is following the structure of a smart contract. It starts with an SPDX license identifier, just to identify the license you want that contract to behave to, like to legally protect you or whatever. Then you have a pragma definition of a version that you limit the compiler versions that can be used to compile that file. If you see that there are some things incompatible, if you see that there are some features you want to tweak, and you are going to find those two lines here into our smart contract as well. The SPDX license identifier and the pragma solidity is stating what is the version that I want it to be compiled to. In this situation, I'm picking a range. Anything from 0.8.2 up to 9, it is good for me. Okay, you can tweak this version range as needed. You are going to see that later in other implementations. And for now, what is important is starting on line 10. We have a contract called storage. The name we put here has no importance at all for what we are going to do later, so you can change this name from contract storage to other things. But those lines here, 12, 18, and 26, they start having actual severe implications on how this smart contract is going to behave. The first very important line is the line 12, where we have something called state variable. When you make a common hello world program, let's say a Python hello world program, a C hello world program, you start with a variable called A and then you print that variable. When you run that again and again and again and again, you are going to have the same output. You don't have persistence between one run and the other. Okay? Can you imagine that the process booting up in your computer, it is assigned on a thread, it occupies a little space in the memory, it's executed, it's terminated, and the next time you're going to execute that, it doesn't use any of the previous resources. Okay? Have you ever heard about garbage, memory garbage, whatever? Then you could eventually stumble into garbage that is in your memory. Okay? This is how normal computing works. When doing a smart contract execution, for example, when we are executing a function here, we have a brand new version of the EVM for us, without any garbage, without anything. It's like every time you are going to go out of home to work, let's say you go by car, you get a brand new car. And when you arrive in your destination, your car is exploded, torn to pieces. And then you click your keys again to come back home, you get a new car, 0 kilometers car. Okay? So what happens if you forget your wallet inside the car? Explodes, torn to pieces, so you lost your wallet. Okay? If you forget your keys, if you forget your dog, okay, that story is turning dark. This is the EVM. Nothing gets carried away between a transaction and the other. Okay? So for example, if we execute that function 18, everything that we execute here, when we try to run that again, it is not going to be there anymore, except for state variables that are persistent, that can carry over data from one execution to the other. That, in fact, they are stored in the blockchain forever. This is something entirely different from normal programs that we do. How do we do persistence when we are writing like a C program or a Python? Have you ever done like you can save a file for your hard drive by state variable in a machine, yeah. Or you can put in a database, like a SQL or NoSQL database, whatever. Or you can put like in a memory database or whatever. For getting persistence, you need to code that. You need to have some system to give it persistence. Okay? It is clear for everyone when I say persistence. Okay? Like I'm doing a long computation. I execute half of it today. I want to turn off my computer, and when I turn it on tomorrow, I don't want to start from 0. I want to start from where I stopped. So I can save that to the hard drive. I can save that for a database, whatever. It is not provided by the language. See? C doesn't provide persistence to variables. Python doesn't provide. No language provides persistence to variable. You need to go there and implement that, right? Solidity is different. When you deploy a smart contract with this line 12, it is separating a place into the blockchain, into all of the nodes that is running. It is separating a small place in the database of those nodes to host that variable, to host that int, that number, that unsigned integer, so that now it has a persistence. Okay? And oh my God, this is the first line of the smart contract. What a backstore. So this is the thing about solidity. We don't take it lightly. Every line of code here is going to have a book of history behind. Okay? It's not like learning a little syntax in C or Python, whatever, that they have very short scope. A function is something that do that. Okay, good. In Solidity, let's look at a function. Let's look at the grammar of a function first. So a contract definition can have contract body elements, and let's define a function definition. Doesn't even fit in one page. Okay. So this is a function definition in Solidity. You start with the word function, like we did, and then you give it an identifier, or you can pick fallback and receive, that are a special kind of identifier. And then you open a parenthesis and you put all the parameters that you want to receive. You close. This is quite similar to other languages. But then you need to determine the visibility, that you have a few options for that. State mutability, that you also have some options for that. Then you can determine if you are going to invoke a modifier or not. Then you can decide to mark it virtual or not. Then you can decide to override all the functions or not. Then you need to specify everything that it returns and all the parameters that it returns. And then after you coded all of these, you don't have anything else to code. You just finish the function and just put 1 or 2 lines of implementations. And this is what is happening. The function definition itself It's way bigger than the function implementation. So it is a function called store that receives a number as parameter that is public, visibility. It doesn't return anything at all. And it's going to execute this. The number is going to be equal to the number received. And the other function, retrieve, is of visibility public. It doesn't require any parameters at all. It is of state mutability view. It returns a uint and just return a number. The definition of the function is very often bigger than the function implementation itself. Okay? That is solidity. You might be considering this a design flaw. Okay? I did as well. I avoided solidity a lot when I discovered that it was like this. But eventually you accept, because you start to understand, it doesn't come easily, but you start to understand why those design decisions are like this. Okay? There are a lot of security consideration, composability considerations for you to understand those design decisions. And of course, if you happen to disagree, oh, this is bad design, there are other programming languages that you can use for programming smart contracts as well. Okay? That sometimes are even worse. You had a question?
Yeah. Is this function overriding the memory inside these specific smart contracts? And then, can I create blocks with just mere data? And how much bytes can I store inside that block?
Okay, I see where I'm going. Like, a very important thing to remember always, this is going to be deployed to the smart contract, to the blockchain, right? And it's going to be one smart contract with one address. So everything that is here, all of those variables and functions are going to be stored inside that address. There, it's going to receive a specific account for that. Okay? I didn't explain that yet, but there are two different kind of accounts. EOAs, externally owned accounts, like the ones that we created. And after we deploy that smart contract, we are going to see that there is another kind of account. It's not an EOA. That is a smart contract account that is going to hold, separate, segregate this amount of data that you are asking, okay? And the limit for that is 2 at the power of 255, something like this, -1. That is basically bazillions of gigabytes. The problem is that you can't use it all because you have some constraints for the blocks. We are all going to see that later, okay? But do not forget that this is going to be deployed to the blockchain and is going to be stored in a specific place with a specific storage, okay? We're going to see that in a few minutes. Just bear with me for a while. This is one function, one entry point, another function, another entry point. This number is not an entry point, it is a state variable. So we have 3 separate things into that smart contract. How to execute it all? How to run the whole smart contract? You can't. You need to trigger a specific function. So for example, I can trigger a store, that's going to do one thing, or I can trigger retrieve, that is going to do another thing. How to trigger both inside the same transaction? You can't. Only if you program another smart contract to trigger those two, but directly you and the smart contract, you can't. Every transaction you do is going to trigger one execution, at most. Okay? That can trigger more things. I could have this store function call the retrieve later, okay? Like, I could do this, could do that. It works. Let's say I have the number 4 and I try to store 6. How much is going to be stored? Number is 4. I try to store 6. How much is going to be stored? Then it is possible. One function can call the other. You see, it is possible. It's going to do that calculation. Okay?
What's the difference between public, like in the first function, and public view in the second?
Yeah, I didn't explain that yet. For now, just know that there are different ways to do that. Okay? There is public, internal, private, and external. And here you have view, you have pure, and you have non-payable and payable. A lot of different things for us to take a look. First, I'm explaining the overall structure. Okay.
What's that gas? That's number.
It is a configuration here that you can display those estimates or not. Don't know if it is default or not. Okay. That is already estimating the amount of computation that is going to be carried out when doing this processing. Okay.
When you added the function, it's changed it to infinite gas.
Yeah. What it is here.
So it's like.
This is the maximum amount of gas that is going to be consumed in that function. Okay. And you don't need to know that now, but what is happening here is that if I try to sum the maximum 256 with the maximum 256 is going to overload and is going to revert. When it happens, the remix doesn't know what to do that, and then it says infinite gas. Okay, but if I do something like this, no, it's going to do infinite gas anyway. If I do like 1, no, yeah, anything I do here probably is going to.
It's not something
Yeah,
important.
it's not important. Yeah, there are some things that I can do that are not going to break, like. See? Just change it. It's not infinite anymore. It is doing nothing, but you see. So it's only pertaining to the amount of computation it's going to do. No workflow, sorry?
No overflow.
Yeah, to answering him why potentially that function was going to infinite is because in some edge situation this could have an overflow and revert. Okay?
You can put like condition inside there.
Yeah, there is if, there is loop,
Okay.
there is a lot of algorithms that you can do. Okay? So in this structure, this is it as an overview. So we compile that smart contract. We now have the bytecode, right? Now I'm going to, let me see how many. Okay, let's do this. This is the deploy and run transactions tab. The first time you connect to it, you are going to be presented with an environment of a virtual machine blockchain. It's a blockchain that is running only inside my browser. You can't access that. Okay, only my browser can. You could if I opened my port and all, but only I can access. The good part of that is that inside this virtual machine, I already have some pre-funded accounts that I can use for sending transactions. So I don't need to ask the faucet, wait for confirmations and all of that. This is great for speeding up the development process. So for example, if you pick that compiled smart contract, come here to deploy and run transactions, pick this virtual machine environment and click on deploy, that transaction is going to happen very quickly. And then on the deployed contract, you have the functions to try them yourself already. Okay? We can use this a lot for exploring how smart contracts work. Probably are going to start by that tomorrow. For example, I can try the retrieve that is going to receive 0. Did we define the number? How it's 0? Shouldn't be null? Well, we did not initialize. How come it's 0? 0 is a value, right? 0 is different from null, right?
The default value is 0.
So, this is important. There is no null for the EVM. EVM doesn't know to deal with a null or undefined. If it's 0, it is very difficult to determine it is indeed 0 or never initialized at all. Okay, so see, every click has a lot of details behind of it. And a function to store. Let's store the number 42. Now when I retrieve, I have 42 again. Now what happened if I deploy that contract again? If I try to retrieve, it's going to say, it's the same contract. I change it from 0 to 42, and I deploy it again. When I click retrieve, it's going to give 0. I just changed it for 42. It's going to give 42, right? No, wrong. I misled you. Sorry. It is a new contract, you see. See how this is confusing. I told you. The code is the code. The interface, the implementations are the implementations. If I change that for, I can deploy it 3 times. Now I have 3 of it. If I change this for 1 here, 2 here, I still have 0 in the order. I can have 3, 2, and 1. Okay, different instances with the same code. See? Those are smart contracts. They can be deployed again, they can be changed, and they can behave differently. This is also a great places, I guess this is going to be homework, but a great place for you to try different things. Let's say I change here from public. What are the visibility options? I have internal, external, private, and public. So instead of public, let's try private. So retrieve instead of public, let's call it private. Let's deploy. Oh no, it's gone. Because it's not public anymore. Let's, instead of private, put it external. Okay, now let's deploy. Okay, it's back again. So what's the difference? Because if I try to do that now, it doesn't work. Because retrieve is external, so it can't be accessed. So if I put here public, now it works. If I put external, it doesn't work anymore. Okay? So I'm not saying this for you to memorize what is public, external, internal, whatever. It's to show that now you have a sandbox to try everything that you want to question. Okay, just change here quickly. It's good for reviewing, it's good for memorizing. Okay. Now for what we are going to finish today, we are going to return to the initial state of that storage.sol. And I'm going to connect here, instead of this virtual machine environment, I'm going to pick this first option, injected provider, MetaMask. Okay, you should do that as well. Connected to the network of your choice, Sequoia or Arbitrum. Let me pick Arbitrum. I have some good testnet amount here on Arbitrum. Connected to it, I can see my balance here. Let me refresh. Connect to MetaMask again. Okay, now it's saying the right balance. This is my account and this is my balance. I don't have those pre-funded accounts anymore. Okay, I just have this balance here. What's happened? Injected provider. Yeah, okay. So this is my balance. I have 0.99984. Okay, this is glitchy. What's happening here? Whatever. And I'm going to compile this contract, storage.sol, and I'm going to deploy it. Instead of instantly deploying like the virtual machine, what happened here? The web page, Remix application, web application, is asking my extension, MetaMask, hey, sign this for me. The transaction is all built. This hexadecimal data, I did not type it myself, see? This is the compile output from the compiler, this contract. When I confirm this, this is going to push into the blockchain, upload to the blockchain, if you want to call it like that, this smart contract at that address. It's done. I can retrieve information from it. It's answering 0. So I can put here on Arbitrum folha. I have just deployed that smart contract there.
So I create a contract to put in the address I want.
Yeah, no, this was calculated for me when I deployed that, okay? So copy it here and paste it there. When I click on retrieve, it comes 0 for me. If I put a number to store, like 42, store, it is going to ask for a transaction.
I created a transaction, which is...
Yeah, we create, look, this is the hexadecimal data. 60, 57, 36, 1D, 0, 0, 0, 0, 0, 0, 0, 0, 2, 8. What? Sorry? 42 is 2A, no? 2A, yeah. 2B is 43. Because you have, is the number 43, where the number 1 is 0, the number 2 is 1, the number 3 is... Okay. You're human, right? So let's just mix here. So I'm going to confirm this. Yeah, you're human, right? So, okay. So good. It's an inclusive bootcamp. So this transaction went to the blockchain. Now when I click retrieve, it is 42. But what if I say that you all can write in that same smart contract? Let me show you how. You copy that address, copy here from the document. You come in Remix after you compile that smart contract. And instead of clicking in deploy, you click in that text box here, add address, and you paste that address here. You need to be connected, of course, to the same network as I am. You need to be connected through MetaMask to the Arbitrum Sepolia. Okay? Otherwise, you are not going to get the same result. You click Add Address. That is going to attach that smart contract to your web browser, what you are doing here inside the IDE. And when you do that, when you click on Retrieve, you are going to see the number I put. And more. You can store a number here. Go there, store a number, like your age or your favorite number, your telephone number, your zip address, whatever.
So you need a transaction to store data, but no transaction to receive.
To read, yeah. Because the data is public, everyone can verify at any moment. You just need access to a node. To put information in the blockchain, you need to convince everyone. To get information out of it, you just need to evaluate. You see? This is the consensus part to kicking in. So you can come here, store a number, click on store. Let me go for the Arbitrum Explorer again.
Does it work even if it's not verified?
Even if it is not verified.
But you have to compile the same contract instead of remix.
You already have it because it's the store. It is the sample. So what I expect to see, oh, my browser froze. Okay, where it is? Here. I expect to see in a few minutes a lot of transactions coming in to store data here. Okay, we are over today. We need to finish the bootcamp for today, but tomorrow we start from here. We see how those interactions work. We tamper a little with the smart contract. We do this for half an hour, 1 hour before we start in the dev tooling to see what we can do with proper developer tools for that, okay? And then we do the testing, the scripts for debugging and all of that. Good? Okay, thank you everyone. Let's get some transactions here. Thank you.